Hi guys, don't forget to subscribe my channel and like this video. Okay, enjoy! Hi guys, Assalamualaikum. We meet again. Welcome to your lecture 2. So for this lecture 2, I will conduct the lecture based on this video. Lecture 2 will be based on the gravimetric and volumetric analysis. So this is the outline for this topic. I will explain about two subtopics, which is the first one is the gravimetric analysis. In gravimetric analysis, I will cover the types of gravimetric analysis and then the principle of gravimetric analysis and then the calculation that involved in gravimetric analysis and of course the application of gravimetric analysis. And then for the second subtopic is about the volumetric analysis. In this volumetric analysis, I just cover the basic principle and then about the types of standard solution and the primary standard solution or secondary standard solution, and then the last but not least about the equivalence and endpoint, because after this topic we'll cover more about the volumetric analysis. I hope in the end of this topic, students are able to identify the types of gravimetric analysis and of course to understand the principle that involved in the gravimetric analysis and volumetric analysis. And of course, students should able to understand the types of standard solution. And last but not least, can differentiate between equivalence point or endpoint. So let's start. In industry, a lot of chemical process involve the method and techniques that related to the analytical chemistry. In analytical chemistry, the method can be divided into two types, which is the first one is the classical methods and then the second one is the instrumental methods. In classical methods can be divided into two types of analysis. The first one is the qualitative analysis and the second one is the quantitative analysis. In this topic, I just cover the quantitative analysis where I will focus about the gravimetric analysis and volumetric analysis. Now we move to the simple introduction about GA, gravimetric analysis, and VA, volumetric analysis. GA is a process of measuring amount of analyte through its mass. Based on the picture given, it involves the process of separation to separate the residue, which is the product, from its sample solution through the filtration process, while in the volumetric analysis is a process to determine the amount of desired constituent by its volume. This process can be done through the titration process. I think both of these techniques you already done in lab session, right? Next, in GA, mass of analyte will be determined, while in VA, volume of analyte will be determined. And of course, as I said, gravimetric analysis involves the formation of solid mass, which is, we call it as a precipitate or product, which can be separated through the filtration process. And of course, in the volumetric analysis, it can be done through the titration process. Okay, titration process. In GA, the final product can give in grams, while in volumetric analysis, the volume of course will give the final product in milliliters ml. I will explain about gravimetric analysis first. Gravimetric analysis, GA, is an analysis based upon mass measurement and analytical balance, an instrument that yields highly accurate and precise data. As I said before, this GA involves the separation method based on the analyte. So this is the setup of the filtration process. In filtration process, it must have an analyte which contain liquid and insoluble solution. When two analytes mix together, it will form product which precipitate in this solution. Next, you must have filter paper and filter funnel. Filter paper give the function to separate the product from the solution. So the remaining product on the surface of filter paper, we call it as residue, while the solution that go through the filter paper, we call it as filtrate. GA is considered as one of the most accurate method of chemical analysis. So this is the general concept for the GA. So first, you must have analytes, which is in soluble form. When two analytes mix together, it will form the product which will precipitate inside the solution. To separate the product from the solution, it must go through the separation process. Okay? In this separation process, the residue that remain on the surface of the filter paper here will go through the washing process first to remove the excess analyte on the surface of the particles, and then after that it will go through the drying process to remove the remaining washing agent. Last but not least, it must go through the weighing process to get the final data or final mass. Now we move to the requirements for the successful gravimetric analysis. So the first requirement is this analysis must involve the formation of insoluble form of analyte, which is from the soluble form to the insoluble form. When two analytes mix together, it must produce the product which will precipitate in the solution. The second requirement is the separation process to remove analyte from any constituent that may interfere. Of course, to separate the product from the solution, they must go through the separation process, which is the filtration technique, to remove the analyte here, to remove the analyte solution, and then give the residue, which is the product of the reaction. The third requirement is the washing process to remove impurities and co-precipitate from precipitate. What is co-precipitate? Later I will explain about it. In washing process, they usually use the solvent with highly volatile. Usually they use the acetone, toluene, or certain alcohol. Last requirement for successful gravimetric analysis is drying process, which to obtain the stable and weighing form. During the drying process, moisture from the washing agent and excess analyte will be removed. So, in this drying process, usually they use a temperature from 100 to 120 degrees Celsius because at this temperature, it will not disturb the form of the product. Last but not least, of course, it will go through the weighing process to get the final mass of product. Now we move to the advantages and disadvantages of the gravimetric analysis. First, gravimetric analysis, no calibration is needed and no standardization is required. This is because the procedure of this analysis just involves the separation technique, which is the filtration process. And then the result is calculated directly from the experimental data obtained. So after you get the product from the drying process, you just need to measure the mass using the analytical balance, and then from the mass that you get, you can calculate the information of analyte needed. And then this analysis is less messy than other methods, which is it can give the accurate reading or accurate result. This result just need the accurate analytical balance, and of course it can be applied to macro samples. So for this analysis, it just required a long experimental hour. this is due to the heating and drying process, because usually the heating and drying process need more than an hour to get the stable and weighing product. Next is about the types of gravimetric analysis. In this topic, I only focus 3 types of gravimetric analysis, which are precipitate gravimetric, volatilization gravimetry, and electrogravimetry. Now we move to the first type of gravimetry analysis, which is precipitation gravimetry. These types of gravimetry analysis is the simplest method, because in this method, it only involves the mixture of two analytes to convert into a sparingly soluble precipitate which can be filtered. What do you mean with sparingly? Sparingly means the conversion from soluble form into insoluble form, which precipitate in the solution. Next, the precipitate or residue will be filtered and washing and drying. After that, the precipitate is converted to a product of non-composition through the ignition process by suitable heat treatment. Last but not least, this product is then wet to get the mass of product. Some example of precipitation gravimetry, such as determination of the amount of calcium in water or milk, or determination of iron content in iron ore. So this is the example of the determination of iron content in iron ore. Now we move to the first example of precipitation gravimetry, which is the determination of calcium in water. Have you ever seen this situation before at your house? This is because of the effect of hot water. What do you mean with hot water? Hot water produced when the water content of calcium. The calcium in the water will react with chromium in the zinc to form the layer of this precipitate. How to determine calcium in water? The first step is the addition of excess oxalic acid in water. Next, certain amount of ammonia was added into the solution and the reaction will occur to form calcium oxalate precipitate. So this is the chemical reaction between calcium ion and oxalate ion to form calcium oxalate precipitate. Next, the precipitate will go through the filtration process, drying process, and ignition process to form calcium oxide precipitate. Next, the precipitate was cooled and wet to obtain the stable weight of calcium oxide. Last step, the calcium content is then calculated as form calcium oxide. The second example is the determination of chloride ion in aqueous solution. How to determine the chloride ion? So the first step is the dissolution of sodium chloride in water. Next, the addition of silver nitrate in sodium chloride solution to form a silver chloride precipitate. So this is the formation or reaction between the chloride ion and silver ion to form silver chloride precipitate. Next, the silver chloride precipitate will go through the filtration and drying process to form a stable silver chloride precipitate. Last but not least, it will be wet to get the mass, and then the chloride content can be calculated as in form of silver chloride. The second gravimetric analysis is volatilization gravimetry. Volatilization gravimetry is different from the precipitation gravimetry because this analysis involves the separating components of mixture by heating or chemically decomposing the sample. the analyte or its decomposition products are volatilized at suitable temperature. The volatile product is then collected and weighed, or alternatively, the weight of product is determined indirectly from the weight loss of the sample. Referring to the diagram, when two analytes are mixed together and being heated, a gas form will be produced. A gas form either can be an analyte or product. Let's say the gas form is analyte, and then the analyte is collected in this area. Then the mass of product can be calculated based on the mass of analyte here indirectly calculated to get the mass of product. The third type of gravimetric analysis is electrogravimetry. In this analysis, the analyte is separated by the deposition on an electrode by an electrical current. In this analysis, the electrolysis concept has been used to separate between analyte and product. Next, we move to the principal steps in gravimetric analysis. In this analysis, it involves 7 steps of principles. The first one is the preliminary treatment. Next is the precipitation process, and then it must go through the digestion process. The next principles is the filtration and washing of the precipitation. The fifth one, drying or ignition of the precipitation. The second last is the weighing process, and last principle must involve the calculation of the amount of the element or radical to be determined. The explanation about each principle will be explained for the next slides. First, I will explain about the preliminary treatment. This process is needed in gravimetric analysis because first, it can eliminate the interfering materials. Second, it can adjust the conditions of solution in order to maintain the low solubility of precipitate. The third one, this process is needed to obtain the suitable precipitate for the filtration stage. There are 5 factors that need to be considered in this stage. The first one is the pH of solution, because pH can influence the solubility of precipitate and possible interference. The second one is volume of the solution, because the volume of solution can affect the amount of product that will produce in the reaction. The third one is the concentration range. An optimum concentration range is needed in the reaction to produce an optimum product. The fourth one is the presence of other constituent, because it can affect the product that will be produced. And the fifth one is the temperature. Certain reaction needed certain reaction to make sure the analytes are in the stable form. Second principle of gravimetric analysis is about the precipitation process. What is precipitation process? Precipitation process is a process which occurs when a portion of dissolved chemicals leave the solution to form solid. In other words, when two analytes are mixed together and lead to the chemical process, it will produce a new product that will precipitate inside the solution. There are 4 properties of ideal precipitate that need to be produced during the reaction. The first one is the ideal precipitate must consist a large crystal that can easily be filtered and can minimize the contamination from impurities. Refer to the illustration here. You can see that the large crystals are easily to be filtered compared than the small crystal because it cannot go through the filter paper. The second properties of ideal precipitate is the precipitate must sufficiently insoluble so that amount of analyte lost during filtration and washing will be really low. It means that the product that will produce must not react with the washing agent, because when it react again with the washing agent, it can dissolve in the solution and it will go through to the filter paper. The next properties of ideal precipitate is stable and unreact with constituent atmosphere, which means it cannot react with the constituent or composition or compound from the atmosphere. Last but not least, the ideal precipitate must non-composition after it is dry. It is to make sure that the product that produced during the chemical reaction contain a high percentage of compound or component that we need in the analysis. Now we move to the mechanism of precipitation. In the precipitation process, it involves the nucleation mechanism. The nucleation mechanism occurs when the number of particles come together to produce microscopic nuclei, which is the large particles in the form of solid phase. The formation of greater number of nuclei per unit time will produce more total crystal of the smaller size. If you can see here, when the small particle, start to combine to each other, it will start to ground and produce a large particle just like this one. So in other words, the nucleic mechanism is about the combination of small product to form a large product here, like this one. Okay. Nucleation mechanism can be divided into two types of mechanism. The first one is the spontaneous nucleation. Spontaneous nucleation will occur on its own. For example, here, when the chloride ion and the sodium ion react each other, it will produce a new product, which is sodium chloride. Then the product will start to combine to each other to form a large particle. In other words, this mechanism can be called as particle growth from the small particles of product into a large particle of product. The second mechanism of nucleation process is induced nucleation, which requires seed particles to get things started. For example, dust, another crystal, or glass fragment. In other words, it needs a nucleation center where the product will embedded on the surface of the nucleation center to make sure the product produce a large particles here. In the chemical reaction, either it involves one mechanism or both mechanisms. Now we move to the third principles of gravimetric analysis, which is the digestion process. What is the digestion process? This process is a phenomenon when a small precipitate which presents in the solution grows to form a large crystal when heated. What is the function of this process? It can improve the purity and filterability of the precipitate, which means it's easy to filter and less impurities. How it works? Usually, this process can be done at elevated temperature to speed the process of agglomeration and coagulation. What is the agglomeration and coagulation process? First, we look into the coagulation of particle process. This process occurs when colloidal particles coming together to change into a large size of particles. In other words, when small particle of product, it accumulates itself to form a large particle of product. Next, we look into the agglomeration of particle of process. This process occurs when the particles sticking to each other on the surface of the particle to form the large crystal product. For example here, when two particles of product sticking to each other and then it continuously to stick it to each other, it can produce a large particles of crystal in. So if you can combine from the nucleation mechanism into the digestion process, it starts with the nucleation process to form a product, and then when the product start to coagulate to form a large particle of product, and then the agglomeration take over to form the crystal. So I can say that the crystal product start from the nucleation mechanism into the coagulation process, the last one into the agglomeration process to form the crystal of product. In gravimetric analysis, it is necessary to form the crystalline particles compared than the formation of the colloidal particle. Why? This is because the crystalline particle give the larger size of particle and also it give the stable form of the particles compared than the colloidal particle which give the small particles. Why the small particles is not favorable in the analysis? First, the small particle is not filterable. The small particle will give a higher surface area and higher solubility which affect to the filtration process. Next, the small particles tend to go through the peptization. What is peptization? Peptization is a process when the particle dissolve and reprecipitate on the surface of the large crystals. By referring this picture, if you can see here, in the filtration process, the large particle is more easy to filter than the small particle because the small particle is easily or tend to pass through the filter paper here. That's why we need the small particles to coagulate and agglomerate to form a filterable product. Previous slide, I mentioned about the peptization. This process is a process which a coagulate colloid reverts to its original dispersed state. For example here, when a large particle of FeOH3 start to peptidize to react with the FeCl3 again, it will produce the smallest particles compared than the original one, which in the form of colloidal particles. Same as this one, when the large particle or the coagulation particle start to disperse again, it will produce the smallest particle compared than the original one. This process also can occur when a coagulate colloidal is washed, when some of them is leached from the dispersion medium. For example here, when this particle is washed by using a washing agent, it can disperse again to form the small particles. So how to overcome this process? The peptization process can be avoided by washing the product with a solution containing an electrolyte that volatiles when the precipitate is dried or ignited. For example, silver chloride is washed using nitric acid in the determination of silver chloride precipitate. It will avoid the silver chloride to disperse and reprecipitate again into the solution. Another phenomenon that possibly occur during the digestion process is co-precipitation process, where this process is normally occur when the soluble compounds or constituents are carried out from the solution by the precipitation. In other words, the impurities or unnecessary compound are carried out during the precipitation growth. There are four types of co-precipitation process. The first one is surface adsorption. This process is the major source of contaminant in coagulated colloids. The surface of the precipitate will contain some primary absorbed ion. For example, silver chloride precipitate will commonly contain some nitrate ion. Referring to this picture, the nitrate ion will stick on the surface of silver chloride precipitate, and then it will be carried out from the solution together with the silver chloride precipitate. This is the way to minimize the surface absorption to occur. The first one is the digestion process, the second one is the washing process, and the third one is reprecipitation process. We move to the second type of co-precipitation process, which is the mixed crystal formation. This process occurs when a contaminant ion replaces an ion in the lattice of a crystal. For example, in the determination of sulfate ion as barium sulfate. Because of the presence of plumbum ion and strontium ion, it will cause a mix of crystal which containing either plumbum sulfate or strontium sulfate. The third type of co-precipitation process is mechanical entrapment. In this process, the impurities are carried out from the solution when the crystal lie together with the impurities during growth. Referring to this picture, when the impurities are surrounded with the particles and the particles start to grow and merge, it will entrap inside the particles and then it will carry out from the solution together with the particles. The last type of co-precipitation process is an occlusion process, where this process occurs when a compound is trapped within a pocket formed during rapid crystal growth. This process is different with the mechanical entrapment because in the mechanical entrapment, the impurities are entrapped inside the particles during the growth of the particles, while in the occlusion process, the impurities are entrapped during the formation of the particles.